right, so in this example, we're asked to rank each set below in terms of increasing lattice energy. So lattice energy can be thought of as the energy that holds these ionic compounds together. Okay, as you probably know, ionic compounds have very high melting and boiling points. If you think of NaCl, which is table salt, you can't boil that, right? You can boil water at your house on your stove, but you probably don't have anything in your house that can boil sodium chloride. So these things are really strongly held together, and we need to understand how they're really strongly held together and what makes some more strong than others. So there's two factors. The first factor in terms of strength of lattice energy is the charge difference. Okay, the charge difference between the ions. And what this means is if you have something that's +1 and something that's -1, that's going to be less attracted than if you have something that's +2 and -2. Okay, so they're going to have a higher lattice energy for something that's +2 and -2 than for something that's +1 and -1. So the greater the charge difference, the greater the lattice energy. Then there's a second factor, and you only consider this second factor if the charge difference is the same. So if the charge difference is the same, then you have to look at ion size. And in this case, the smaller the ion, the greater the lattice energy. And this is just because the two nuclei are closer together. And if we were going to look at an example of that, we could look at LIF versus KBr. So if we look here, Li and F are higher up on the periodic table than K and Br. So these ions are both +1 and -1, +1 and -1. The charge is the same, but these ions are smaller. So the nuclei are closer together, and this would have a greater lattice energy than this. Again, you only consider the ion size if the charge difference is the same. If the charge difference is greater, it's going to have a higher lattice energy. So, in order to do this, the first thing we need to do is we need to find the charge on these ions. So this is back to, chapter 2 of general chemistry. So we have NaCl. So Na is in 1A, so it's +1. Cl is in 7A, so it is -1. So we have +1, -1. We have K and Br. K is here. Oh, you can't see that. K is here, Br is here, so we again have +1, -1. And then finally we have NaBr. Na is here, +1, and Br is still over here, -1. So these are all the same charge. So in this case, we need to consider the size. So if we want increasing lattice energy, it means we want the smallest first. Remember that when the charge differences are the same, we want to use the smaller the size, the greater the lattice energy. So in this case, we want the biggest ones because we want the least lattice energy first. This gets complicated and takes practice. All right, just knowing which order to put them in. So we want to put the smallest first, which is the biggest ions. So since K is lower on the periodic table, it's bigger than Na. And therefore, if we have KBr and NaBr, notice the other one has Cl, which is bigger than which is smaller than Br because it's higher up on the periodic table. So we want to compare KBr and NaBr. We're going to find that KBr is the absolute smallest because it's the absolute largest ions, and that's going to be less than NaBr, which is going to be less than NaCl. Next one, we have NaF, ALN, and MgO. So we have Na and F, which is +1, -1. Na is in 1A, F's in 7A. Al and N. Al is in 3A, so it's +3. N is in 5A, so it's -3. And then we have Mg, which is in 2A, so it's +2. And O, which is in 6A, so it's -2. How are we going to rank these? Well, we want the smallest first. The one with the lowest charge difference, +1, -1, the charge difference here is 2, and you could think of this as the charge difference of 6, and this is a charge difference of 4, so 3 minus negative 3 is 6. Okay, so this has the smallest charge difference of 2, therefore it's going to have the lowest lattice energy. So we have NAF, which is less than MgO, which has a charge difference of 4, if you will, and then finally ALN, which has a charge difference of 6, if you will.